Hi, my name is Richard Moore, and this is my Physics 2 Lab 5. Introduction Instructions. The instructions for this lab were to determine the time it takes for a magnet to fall through an aluminum foil tube, both experimentally and through coating. The two steps seen here were to be used, being number 1, drop the magnet 5 times, taking the average time of the 5 drops, and number 2, use a coating model to determine the perfect road drop time of the magnet. In order to perform these evaluations and all steps required, the lab instruction manual was to be followed and the starter code was to be used. Purpose. The goal of this lab was to determine the drop times of the magnet both experimentally and through coating, comparing and evaluating such metrics. Overall, though, the purpose of this lab was to learn more about the principles of magnetism and Faraday's law, a topic that has been discussed very frequently during class. Results preview. Through this lab, it was determined that the coating drop time was less than that of the experimental drop time. The experimental drop time was on average 1.538 seconds, while the coating drop time was 1.384 seconds. Models and principles. As can be seen here are the models and principles used throughout this lab, being Faraday's law, Newton's third law, and the magnetic force on a wire equation. Rationale. Faraday's law was used since it allows for the calculation of magnetic flux and other important variables needed when dealing with magnetic situations. Newton's third law was used since it allows for the determination of opposing forces of a stable system, and the magnetic force on a wire equation was used since it allows for the calculation of force, being integral to situations dealing with magnets. System and surroundings. The system in this lab was the magnet in the aluminum foil tube, while the surroundings was everything else in the lab room not directly impacting results of the experiment, including tables, chairs, etc. Initial conditions. The initial conditions for this lab were that the magnet is dropped from rest and caught at the bottom of the aluminum foil tube, that the tube is held vertically, and that the north end of the magnet is known before dropping the magnet. Experimental data. In the experimental portion of this lab, the magnet was dropped 5 times, resulting in these following times: 1.51, 1.71, 1.47, 1.64, and 1.36 seconds. When averaged, this led to an average time of 1.538 seconds. Coating. As seen here are 2 pictures of the coating from this lab. In the first top picture is the geometry of the tube, including variables such as length, width, and radius. And in the bottom picture is the properties of the magnet, including, very importantly, the magnitude of the magnetic dipole moment, as calculated from Lab 3. As seen here are 2 more pictures of my coating, including important functions such as the magnetic field of the bar magnet and F net being equal to F gravity plus F magnetic. Also very important seen here is the velocity and position of the bar magnet. Ultimately, using this coating, it led to a time in the tube of 1.384 seconds, as can be seen here in this graph. Comparison. The experimental drop time was on average 1.538 seconds, while the coating drop time was 1.384 seconds. This presents the idea of an inaccuracy being caused by various potential errors during the experimental procedure. These potential errors are as follows: that the tube was not held directly vertically, which is a possibility, and that the magnet might have been given an initial velocity when dropped in the tube, resulting in improper results. What if? According to this what if question, in this situation, the magnetic force would increase. Therefore, the magnet would take more time to fall due to the increase of the magnetic force acting upon the magnet, opposing the force of gravity. And according to this what if question, in this situation, cutting holes or slots in the tube would reduce the current flowing through them, and therefore this would reduce the magnetic force. This reduction in magnetic force would allow for the magnet to fall faster, since there is a lesser force opposing the force of gravity than before. In conclusion, overall, the drop times of the magnet through an aluminum foil tube was determined both experimentally and through a coating model. The experimental drop time was on average 1.538 seconds, while the coating drop time was 1.384 seconds. Therefore, it can be seen that the coating drop time was less, potentially being due to experimental errors. Thank you.